we're going to find the composition of f with g and the composition of g with f and their domains, where f of x is 2 to the x and g of x is x plus 4. So first of all, we'll look at f of g of x, which is what f takes g of x to. Since g of x is x plus 4, and f uses its input as the exponent on 2, we get 2 to the power x plus 4. There is no restriction when x goes to x plus 4 or when we exponentiate. Both have domains which are all reals, and so the domain of the composition of f with g is equal to negative infinity to infinity. Now as we look at composition of g with f of x, that is what g takes f of x to, where f of x is 2 to the x. And what does g do to anything? G adds 4. And so we're going to have 2 to the x quantity plus 4. This time x, first of all, gets exponentiated. And I'm sorry I wrote e instead of 2 here. And then we add 4. And so there's no restriction on either of these. The domain of the composition of g with f is negative infinity to infinity. In our second problem, f of x is log base 4 of x, and g of x is x minus 4. So the composition of f with g of x is what f takes g of x to, what f takes x minus 4 to. And f takes the log base 4 of whatever it sees. So we get the log base 4 of x minus 4. So x, first of all, goes to x minus 4, which allows any real number, but then to log base 4 of x minus 4. And here we have a restriction. X minus 4 must be greater than 0 because the log only accepts positive values. So x minus 4 greater than 0 implies x must be greater than 4. And so the domain of the composition of f with g is equal to the open interval 4 to infinity, not including the 4. For the composition of g with f of x, the result is what g takes f of x to. And so this will be g of log base 4 of x. G subtracts 4 from anything it sees, so it's the log base 4 of x quantity subtract 4. This time, x first of all is taken to log base 4 of x, and then 4 is subtracted from log base 4 of x. So the restriction occurs in the first step where x must be positive, because the domain of the log base 4 is 0 to infinity. And so the domain of the composition of G with f is the open interval from 0 to infinity. There's no further restriction because we can subtract 4 from any real number. And our last problem here, we have f of x equals log x, common log x, and g of x equals x to the fifth. It's called a power function, x to the fifth, where the variable is in the base. So composition of f with g of x takes x to what f takes g of x to, and g of x is x to the fifth. F is the common log, so we end up with the log of x to the fifth. So x goes to x to the fifth, which goes to the log of x to the fifth. So x to the fifth, x could be any real number, but in the second step, x to the fifth must be greater than 0. If x to the fifth is greater than 0, we notice that a negative number to the fifth would be negative, and so we must have x greater than 0 because we're not allowed to have a negative power as an input to log. And so the domain of the composition of f with g is the open interval from 0 to infinity. In the other direction, we have the composition of g with f of x, which is what g takes f of x to. And f of x is the common log of x. And g raises whatever it sees to the fifth power. So we're going to have the common log of x, parentheses, to the fifth power. So x goes to log x, which goes to log x quantity to the fifth power. Here the restriction occurs right away because the input to the log has to be greater than 0. We can raise any number to the fifth power, so there's no further restriction. And so the domain of the composition of G with F is the open interval from 0 to infinity.